All right, so we're going to go ahead and we're going to dive into MIT's Scratch. Now, some of you might have used this program before for, programming or playing games. A lot of you like to come over here to explore and start seeing some of the other games that other people have made. But we're going to actually make our own today. It's not going to be a simple game. It's not going to be a simple game. It is going to be a simple game. It's not going to be Fortnite or anything crazy like that, but here is our design window, okay? Over here is what's actually happening in the game. We can click this right here to make it full screen so we can see it better. This button right here starts our game, and stops our game. Our game doesn't do anything right now because we haven't programmed it to do anything yet. Over here, we have all of our different programming blocks. Now, a lot of times when people program, they write it out, using their keyboard. They type in things, they write that kind of stuff out. We have the advantage of we can use these blocks to kind of simplify a lot of that stuff there for us. And since for some of you this might be your first time ever programming or making a game, this will make it pretty easy for us. Over here we have any of these blocks to do with motion right here. Anything that has to do with the looks of our character, make him say things, change his costumes. Costumes are just kind of like his skins if you play games, or just what it looks like. We have sounds. We have events. These are kind of like what starts our game or starts with different triggers. We have our controls. Okay, these are our conditionals. We have our loop statements, which means something. If we put a loop statement in there, repeat or forever, if we put this on here, it's going to do whatever we put inside of this puzzle piece forever. Or if we want it just to do it 10 times, we can put it inside that puzzle piece. These loops are important. These ones right here, these are our conditionals. If something, whatever puzzle piece we put in there, then do whatever we put in this space, okay? This will help us to make decisions with our game and the characters and everything inside of it. Sensing, this kind of helps us to kind of have the computer tell us what's going on and use that information to do other things. For example, this one right here, if touching something that's the color purple, then you can activate it. Operators, this is where we can use math, and then our variables. A variable is like a box that we can put numbers or information in and then call it something else. We could label the box. If you were going to move, you might have a box and you label it kitchen, and then you put your forks and spoons and knives and plates and all that inside that box, but it's all inside of that box. Well, this will let us make our own variables, our own boxes if we want. Okay, so we're going to make a simple game. I think what we're going to do is we're going to make a pterodactyl game where there's fruit falling from, up in the trees, and we have to catch it with the pterodactyl. And every time we catch the fruit, it advances our score by 1 point. And then we'll have the game just kind of go on forever until you get bored of it, and then you can compare your high score to the high score of your friends. So the last thing we need to know before we get started with this is our programming area. This is where we drag any of our puzzle pieces, our programming pieces. And we also see right here a representation of whatever it is we are programming. In our game screen right here, we have a cat right now. And you can see the cat right there. This tells us that anything we put over here is going to apply to our cat. So if we came here and we did next costume, and then right now it's not going to do anything, but if we throw this little green flag here, every time I click that green flag, you can see he's changing his costume. For the cat, it just kind of makes him look like he's walking, but other sprites have different appearances to them. A sprite is just what we call a character or another picture or image we use in our game. So I'm going to go ahead and delete the cat. He's gone. Okay, because we're making a pterodactyl game. We're not making a cat game. We're making a pterodactyl game. You can actually, though, if you like the cat better, or if there's some other thing you want to use, you can do that. That will not break your code. You can use whatever animal, person, whatever you want. Okay, so we're going to click right here on Choose a Sprite and scroll down until we find the pterodactyl. Okay, now we have a pterodactyl instead of a cat, and we can see that we have the pterodactyl's programming space right here, and we have him in the game. Now, if you think back to math, you've probably seen a coordinate grid. You have your x-axis on the bottom, your y-axis, on the side going up. That's usually what we use. X and y are just variables, so we can actually call them different things sometimes. But the standard convention is x and y. And if we look at our pterodactyl right now, he is sitting at x 80, y 44. Okay. I don't want my pterodactyl to be flying up here because we need room for the fruit to fall so you can catch it. So we're going to try and bring him down. So if he's sitting at y44 right now, and this is our up and down, what do we got to do? Well, the first thing we can try is we can try lowering this number down. Okay, I went to 20. 20 is less than 44, and he dropped. I'm going to put in 0. Okay, so 0 puts him here, but it didn't bring him all the way down to the bottom. So what this is telling me, and I'm going to pull up a paint thing for a second. Okay. Normally we think of our x and y like this. Here's x, here's y. What this is telling me is that our coordinate system over here actually looks a little bit more like this, where we have positive numbers over here, negative numbers over here for our x-axis, and we have positive numbers here, negative numbers right here for our y-axis going up and down. Okay, so none of this is going to help me with my game. I don't want any of this stuff in here, but it does help us understand the coordinate system we have to use to put all of our little pieces onto our board. Okay, so I can actually just trash can that sprite right there. Okay, there we go. So we have our pterodactyl. So if we think now that the middle of that coordinate system is 0, 0, 0, 0 is going to put him right there. So I think I will start him in the middle, but we're going to lower him down. And if I remember correctly, Scratch's bottom is like 182, so we'll do minus 190, okay, minus 200, okay. So we can actually keep going lower than that, but I want him to at least be visible to us. So we're going to go up our axis a little bit, and we're just kind of trying numbers until we find something that makes sense. Okay, 125. That looks good. He's on the bottom of the screen. He's ready to catch his fruit. All right, let's play our game. Okay, nothing happened. That's, not what we want. Now, why, though? Okay, think about it. Why is nothing happening? Well, the answer is we haven't programmed it to do anything. All we have done is added a pterodactyl. Okay. He's not flying around. We have costumes to make him look like he's flying. Okay, see? Oh, hey, look, he's dancing. He's dancing. Okay, anyways. So, we want, oh, wait, now he's like, oh, I guess that works. Looks like he's trying to catch the fruit in his mouth, but nothing's happening. So now we're going to start looking at our coding block. So we look right here. We do have the pterodactyl selected, okay? So we're going to start with when the green button is clicked. This is how we're going to start our game. We're going to click that green button. Almost any Scratch program you make has to have this at least somewhere in the program to start all the actions and get it going on. Okay, and so when we click that, we want to go ahead and we're going to throw a forever loop. This means it's going to repeat this over and over and over and over and over and over and over until you get bored and close out of the program. Okay, so we want this to happen forever. And now we got to check. Okay, we're going to go ahead and program it so our left and right arrow keys are what determine if he's moving or not. So we come here into our conditionals, and we're going to use this block right here. If blank, then blank. Okay, and we have to put that inside of forever because we want it to happen over and over and over. If we put it out here, it isn't going to trigger. Okay, so it goes inside of the forever block. And if you look at our puzzle pieces, you can see the shape of this and the shape of this block. That tells us that those will go in there and those will fit up and they'll match and they work great. This one here is different, though. It has 2 points on it. So we have to find something that will fit in there. So to me, the most natural idea would be if we push the left key, then go left. Well, the computer doesn't know what pushing the left key is or going left is until we program it. The nice thing about Scratch is they've programmed in some of these basic ideas for us. So we can come over here to Sensing, and we will find this block right here that fits perfect into there. Now, ignore the fact that I grabbed the wrong block, okay? Like I said, we're debugging. We're kind of going through this as we're together. I might make some mistakes, and we'll have to catch them and fix them. A lot of programming is making mistakes and fixing them. That's debugging. It happens all the time. So what we really wanted was if space is pressed. Now, I don't want the space key to be the one that moves him. Okay. Right now, if I push my space key, it does nothing. There's two reasons for that. One is we haven't programmed or told the computer what we want it to do. The other thing is none of this program is going to start until I click on go. So if I hit go and I push my space key, nothing happens. We got to tell it what to do. So we're going to go ahead and tell it when I push the space key, we are going to move X or change X. I forget what they call it. Change X by. And we're going to have it changed by 10. Okay? So now when I push the space key, there we go. He's moving to the right. Positive numbers go to the right. Yeah, it's mirrored, but that's still the right. So positive numbers go to the right, negative numbers go to the left. So I can now go to the right, but it's not the button I want to push to do it. So I'm going to click right here, and I'm going to click right arrow. So now every time I hit the right arrow, he's going to move. But pushing the left arrow means I cannot get him to go back. So take a minute. You can pause if you want. See if you can figure out how to make the movement to the left work. So go ahead, do that if you want. And I'm just going to assume you've done that if that's what you're going to do. So we're going to need to basically mirror what we did before, but with the left arrow and by changing our X to a negative number, because negative is going to move us that way down our number line, down our axis. Positive makes us go that way. And for Y, it's up and down. So we come here and we're going to throw in another if statement. Now, it's going to check first if the right arrow is pushed, and then it will check for the left because of the order that we put those in. Okay, so no, I keep grabbing that touching block. That's not what I want. There we go. All right, so left arrow, and we can just right-click and duplicate this. Okay, we could also come over here and find it as well, but we need to change that to -10. And now, when I push my left arrow, our pterodactyl goes left, he goes right, and we have a moving character for our game. Okay, perfect. That's a great start. Now, let's see. Now, let's say when we first start this game, if we've been playing around and he's over here, let's say we want him to start in the middle. So we can come over to this motion thing, and we're going to pop this block in right here, and we're going to start him at 0x and -125y. Okay, that's going to pop him right back here. The x is at 0 because our coordinate grid goes up and down, left and right, and that's 0. But he's down here because we want him to start at -125 to start him down here at the bottom. If I put this to 0 or some other number, he'll move up and down. Okay, so that works. We have a moving pterodactyl. Now, he can't catch any food, but we can move him as long as we first push that green button. And now I can move him over here, and then I want to reset the game. Just hit the green button again. He goes back to the beginning. Okay, so we are set there. We have a moving pterodactyl. Now, we're going to start on the fruit. But before we do that, we're going to set a background. So I'm going to come right here, choose backdrop, and I'm going to find something that makes sense for a pterodactyl. Pterodactyls through the galaxies. We're on the moon. Let's go with the tree. Fruit falls off of a tree, so that makes sense. Okay, so there we go. Pterodactyl, bottom of tree. He's ready to catch fruit. Okay, so we're going to add another sprite. We're going to come right here. We're going to choose a sprite. We're going to make him try and catch, well, there's apples. Let's go for oranges. We'll go oranges, okay? So we have that. Now you'll notice right here, you see an orange? Now it's a dinosaur, and our code shows back up. So we can give the dinosaur its own code, and we can give the orange its own code, okay? So you have to make sure you're paying attention to what is showing up here to know which one you are selecting. So this is actually, I'm going to let you in a secret. This is actually the second time I've tried to record this because the first time my computer crashed and I lost all of the footage. So hopefully that won't happen again. And hopefully we're not missing out on any of the explanations I gave in that other video. So what we want to do with this orange is, my goal is it's going to start up here on the top and it's going to drop down and fall. If it touches, this is where we got to kind of think through our thing. I was going to draw it, but that's not going to work right. Maybe I'll throw in an explanation later on that. So we'll go back to our code. Not that we don't care about our costumes right now, the code, okay? And if it falls, we're going to have it fall from the ceiling. If it's not touching the pterodactyl, keep falling. Otherwise, we want it to check and see if it's touching the ground. Because if it touches the ground, we want it to go back down, back up to the top and fall over. If it touches the pterodactyl, we also want it to go back to the top, but we want it to add to the score so you can earn your points. So we check, double check. We are selected the orange. We have that selected, and we're going to come over here. So when we click the green flag, pretty much everything we do is going to start with that green flag command, okay? So when we click the green flag, we want the orange to fall. And we want this to happen over and over and over and over and over and over forever. So we're going to use our forever loop block, okay? Now we got to start checking some conditionals, okay? That's just our if-then statements. If this happens, then this happens. That's what I mean when I say our conditionals. So if, okay, and we want it to sense if the orange is touching the pterodactyl. So if touching, we got to change this from the mouse pointer to the dinosaur, and any sprite you put will show up here. So if touching the dinosaur, then what do we want it to do? Well, we want it to reset, okay? So we're going to tell it to go to, for now, 0 and 100. We'll just try 200, okay? So run that. Okay, and right now it's not touching the dinosaur, so it isn't going to do anything. If I drag it, it does. It resets it up there. Now, the downside to this, we'll come back to that actually. So if it touches the dinosaur, and we can test it by touching it to the dinosaur. Now, it doesn't care about his wings, really. It just cares about his mouth. If it's touching it, go back to the top, okay? Now we want it to do some other stuff. So if it's touching, go up there and add some points to the score. We don't have a score system yet, so we'll add that later. Okay, we'll come back to that. What I like to do when I'm programming is I kind of choose a task. I'm like, okay, I want it to do this, and I make it do that. And then I do the next task, and I make it do that. And sometimes that means I have to go back and fix things. A way to solve that is to write it out on paper beforehand, your general idea, make a plan. But we're kind of winging it. Okay, so now we want it to fall. Now, I'm going to go back to control, and we have this other conditional that we haven't looked at yet. If, then, else. And that's probably going to be a better fit because we want it to do a couple different checks. Okay? So if dinosaur 3 is touching dinosaur 3, then reset. Okay? And we can get rid of this. And we're going to plug this in where that was before. Okay? So if touching dinosaur 3, then go to x0, y200. That resets it back to top. Else, well, what do we want it to do? Well, we need it to check and see if it's touching the ground. Otherwise, we want it to keep falling. So in that case, we probably want to use another if, then, else. If touching the ground, then reset. Otherwise, keep counting. So, not keep counting, keep falling. So if we're going to do it to change y by 10. Now remember, positive numbers on the y-axis go up, negative numbers go down. So we are going to go ahead and make this minus 10. Okay, so now he's falling, and you'll notice every time it hits the dinosaur, it's jumping back to the top. Now, if I move the dinosaur out of the way, it gets stuck. And it doesn't jump back to top because it doesn't have a command if it's touching the ground, and it doesn't have a way to touch the dinosaur now because it already fell down below him. So that's fine. Okay, if worst case, we can just hit stop and hit reset. However, that'll work for the dinosaur. It won't work for our orange because we haven't given it a home to start the game at. So when it starts the game, we're going to put it right here, go to 0, and we're going to go to positive 182, or just to make sure, 200. Okay, now when I start the game, it's going to restart at the top every time before it goes into this forever loop. Okay, so this only happens one time because it's not inside of a loop. A loop is what we call something that makes the program repeat. Okay, so there we go. It's falling. we're hitting him, and it resets. So finally, now we're going to come over here to our operators, because here's a problem I found earlier. We do have this very nice sensing block. Touching, okay? If touching the edge, it looks like it would work great, but right now when it goes to the top, what's it doing? It's touching an edge. This doesn't specify which edge we're after. If I drop this down, though, all of a sudden it falls again. Okay, so we have a glitch or, a bug in our program right now that we got to fix. So what I'm going to do is we're going to use this other cool block under operators of and. Okay, so we're going to throw this in here. And now we can stick this side. So if touching an edge and something, well, and y is less than some value. So we're going to come here with our inequality. Equality I can't remember right now. Oh, well. But we're going to find that. And we get to come over here. And it gives us this nice y position. Okay. So if its y position, it's up and down, is less than 50, okay, keep falling. And if it's not touching an edge. So now it seems to be working. We can move left. Okay. We can move that way. And apparently he can touch it now, but okay. So if touching an edge and y position is less than 50. This might not be the right number. I'm not sure, but since we don't have it doing anything, we need to set that first. So if it touches an edge and the y position is less than 50, duplicate. We can just duplicate this and there. Okay. So see? Debugging. Fun stuff. So if it's touching the edge and y position is less than 200. Let's try that. Else. Okay. I may have overcomplicated this. So I'm going to try that. I'm going to change, so instead of having that else the condition, okay, we're going to change it into just a normal if then. Drag this into there. And we're going to check both of these things. Otherwise, we're going to drop down. Okay, so reset it. There we go. So when I had it set as 200 there, I had to think about that for a second. What it was doing is it was touching an edge when it reset itself there, and this up here would be touching 200. We don't want that. So we want a smaller number. Let's just say less than 100, okay? So now what that's going to do is it's going to keep falling forever and ever and ever, and then when it hits the bottom, the ground, it jumps back up to the top, okay? This 100 right here is important because it's basically drawing a line about here, and it says as long as it's underneath this line and touching an edge, reset. If it was above that line, it doesn't care, and if it's touching the edge up here, it doesn't care unless both of these things are happening, the and. I know this code's probably a little crazy, so let's walk through it. So when we click the green flag, it starts the game. When we start the game, wherever the ball is, it's going to take it to x is 0, y 200, so up here. Then forever, it's going to repeat this. If it's touching the dinosaur, then go back to the top. The top is 0, x 0, y 200. Otherwise, or else, if it's touching the edge and its height, its y position is less than 100, and that's about here, okay, go back to the top. If it's doing both of these things. If it's not touching the dinosaur, it's not touching the edge, and it's not less than 100, change y by -10. So keep following. All of this code right here is just to check, are we touching the dinosaur? Are we touching the ground? Otherwise, have the fruit fall, okay? So we almost have our game done. The last thing we want to do is set up our score, okay? So we're going to make a variable for this, okay? We're going to make a variable. So come to variables. We're going to call this my score. And this we have the choice to make it just for the dinosaur or just for the fruit. So we want it for everything. It really doesn't matter in our case, but my score counts for everything, okay? And they already put up this nice little display right there for us, okay? So now we got to decide where it makes sense to give us our score. To me, it makes sense every time it touches the dinosaur, okay? That's going to get at our score. So if touching the dinosaur, we're going to reset the fruit, but we're going to add another block, and that's going to be in our, it's been a while, variables. Change my variable by 1. So we'll plug this in right here. But this isn't my variable. We called this my score. My variable is some other variable that we aren't concerned about. So we're going to hit my score. Okay, 1, 2. And now we can see every time it touches the pterodactyl, the score is going up, which is what we want it to do. And we don't really care for this game to make the score reset. If you want to try and figure that out on your own until I make another video, feel free. Go ahead and do that. But it's just going to keep going up forever. So now let's reset our game. The other thing we have to check, see, when I reset the game right away, our score didn't reset. So we want to do that as well. So when up here, underneath our forever section, we're going to go set my score to 0. Okay. Now, whenever we hit that green flag, okay, we'll watch our score go up. We can hit the green flag and it resets. So now we have a working game. Okay, so let's go ahead and let's try and move our pterodactyl. Pterodactyl moves out of the way. We're not getting any score. Touches the pterodactyl. Our score is going up. So we're so close to being done. But this is a boring game. Do you know why? Well, it's because the pterodactyl can just sit right here. I don't even have to touch my keyboard. I can just let it play. And my score is going up and up and up. So that's not going to work. So we'll stop the game, reset, and stop really quickly. The last thing we want to do is we want this fruit to start in different places. I still want it to fall from the top of the tree, but I want to start in a different place after the first time. So once again, pause the video, think about it, see if you can figure out how to do this, okay? All right, I'm going to assume you've paused the video, you've thought about it, maybe you have your answer. If you said that we need to find a way to change the x value, the left or where it is left and right, then you're correct. Okay, so we're going to find our motion, okay, and we're going to do the set x value, okay. Actually, there might even be an easier way. Because if you look at here, we have a round puzzle piece here and a round puzzle piece there. If we go to operators, let's see if we have a random. There we go. Pick random. Pop that in there. And remember, the way this axis works is we have 0 in the middle, so we want it to start over here and over there. So we're going to go from -200 to +200, okay? And now what that's going to do is anywhere from over here to over here, it's going to choose a random left and right, but our y value is always going to be 200. So it's always going to show up here. So let's find out what happens when we start our game. Okay, there we go. Our fruit is showing up in random spots. Now, I mean, it's not the hardest game in the world. The pterodactyl's wings are spread out. You know, he's moving around. But this game shows us a couple things. All right, so we learned about, well, a lot of basic computer science ideas, things that computers cannot just, you know, follow human directions by themselves. You have to program them. You have to tell them exactly what you want them to do. They don't know what go left means. You have to tell them what that means. We learned about conditionals. Those were the ifs and thens and elses, those little loops that we use there. We also learned about our loops as well. Repeat forever, repeat 10 times, 15 times, however many times. We reviewed the idea of coordinates, x and y, x typically being left and right, y typically being up and down, positive values going one way on our axis, negative values going the other. And we also kind of looked at the idea of a variable where we can use a letter or a box to put our information in, and we can call it by that variable name instead of what it actually is. So our position, however far right or left our pterodactyl was, we called that the x variable for his position there. For his up and down, or for the fruit falling, we used the y variable to describe its height as it falls. We also had a score, which we called that variable my score, which acted as a box to hold all that stuff. So anyways, I hope you guys are having, everything's going well for you guys, and I will see you next time.